we're going to go over constraints, data integrity, and do a little demos. So primary key constraint, most people have heard of this one. You know, you put it on your table and it enforces kind of uniqueness across all of the values in that column. That column has to have a not null on it, so you can't have any nulls in it, and you're only allowed to have one primary key per table. The unique constraint is another one, and it's like primary key. It forces uniqueness, you know, of all the values in the column. But unlike primary keys, it allows nulls to be one of those values. And you can have as many unique constraints on the table, you know, one per column, as many as there are columns on the table. So there's that.
So nulls are not considered duplicates then?
So the question was, nulls are not considered duplicates. You can't have two nulls. You can have one of them.
Okay.
Yeah. But primary key does not. Yeah, only one. Yeah. You can't have a duplicate null.
Right. Okay.
Primary keys don't allow nulls, period. They require a not nullable column. And then there's the check constraint. This enforces domain integrity. It's a little vocab word we'll get to later. So the data must conform to whatever constraints you have on that column. Say you want a value within a certain range, you can enforce that with a check constraint, or you want a date later than or before a certain date, you can enforce that constraint as well. You can reference when you define it in multiple columns, saying this check constraint in this column here, it must be a value less than it's the other value on the other same row, but in a different column. Default constraints, most of us have probably heard of these as well. I can use them to get around, you know, a not nullable column. They can also be dynamic, like you can have the default value as get date or some time zone offset thing. So you can kind of have a timestamp thrown in the table automatically, and you don't have to reference it when you're doing an insert. And you can also override it with actual values if you wanted to update or insert a specific value in that column that you have defaulting. Foreign key constraint, another very common one. It's when you have two tables and you want a value in the second table to always match a value in the first table. So the second table will be the foreign key table, and it references a primary key on that first table. When you define it, you can, by default, it will scan through all the tables in your foreign key table and look for matching values in your primary key table. And if all of them match up, then you're good to go. But if some of them don't match up, then you can't create the foreign key constraint. If you add the with no check option, it won't scan both the tables. It will create that foreign key primary key relationship, and all new values going into the foreign key, that secondary table, will have to match, have a matching primary key. So that allows you to create a foreign key relationship and then go back and fix your data. A few vocab words here, around data integrity. So there's domain integrity, which is check constraints, and that's an individual value is kind of the domain or a column. The entity integrity kind of refers to the whole table, looking at unique constraints, primary keys, and referential integrity is between two entities. So primary keys, foreign keys. And on the demos. All right, we're gonna create the database that's gonna have one table in it. We can look at the data here, and we're gonna look at primary keys. So select star from the table, We've got four rows in there. When I created the category ID column, it's just an integer. It's not an identity. There's no primary keys on it. So since there's no primary key, we can do an insert where the category ID will say a 4, even though there's already a 4 in there. And we'll run it. It lets us create it. There's no unique constraint or primary key constraint. So now we've got probably bad data in there. So with primary keys, the column has to be not null. So let's add a not null, alter table, categories, alter the column to be not null. Now let's try to add the primary key constraint. So you say alter table in the table name, add constraint, and then you name the constraint. I don't like to go with the default SQL Server constraints because they aren't too readable and they don't follow our coding standards. So we say primary key, and we want it clustered, if you remember from the index training, on category ID ascending. So when we run that, it won't let us because it scans it and it says duplicate key was found in the table, and the duplicate key value was 4, which we saw earlier with the food and the rope categories. So let's update categories. We'll change the category ID to 5 for that rope record. Now we can see we should be able to create the primary key there because we have not null on that column and there are no duplicates. So let's run the primary key thing again. Oh, we were able to create it. Try to insert another rope with 5. It says violation of primary key constraint. Cannot insert duplicate key in the table. The key value is 5. So we can change that category ID, up it by 1, and now we can insert that data.
So if you create an index, a clustered index on an existing table, a heap or whatever, does it go reorder everything when it does that or something?
Yes.
It must, right?
Yeah. Okay, so unique constraints. Let's add, well, let's try to add another primary key to our table. Say we want to have unique titles in our table, and we can't. It says this table already has a primary key defined on it. So looking at our data here, let's create another row record with the category ID of 7, which will match our primary key constraint, but we're going to have the same title and description as the previous one, so some paracord rope. Now we can see there that we still have a unique category ID, but we've got duplicate titles and description. And we want to add a unique constraint to the description field. So we say alter table, add constraint, we name it unique, and then description, which is the column we want to add it to. Oh, won't let us. We cannot create it because duplicate key was found. Duplicate key is the duplicate key value is paracord. So let's just delete that last row that we inserted. Now we have unique descriptions. Add the constraint, it lets us. So let's see what it says when we rerun that previous insert statement. It says, oh, violation of unique key, not primary key. Unique key constraint, and the name, cannot insert duplicate key in the table. Duplicate key value is paracord. So when we change that description, now it lets us work through that unique constraint because we inserted a 7 and cotton rope instead of double paracord. So check constraints. Let's try to put a check constraint on the reorder amount column, and it's going to be where it's going to enforce that the reorder amount has to be greater than 0 and less than or equal to 10. So let's see what happens with this table, because we have values that are outside of that range, and it won't let us create it because there is conflicted with the check constraint. Conflict occurred in the database table and the column. So let's bump that reorder amount up to 500 because we have 3 500s, and it lets us create it. That's the syntax for creating a check constraint: is alter table, add constraint, and then you name it. Check, so it's not a primary key, it's not unique, it's a check constraint. And then you can have multiple criteria for that constraint. So now let's try to insert into that table so a fishing pole, trout pole with the reorder amount of 0. And it blocks us. It says insert statement conflicted with that check constraint on reorder amount. So that's what we get when we try how we get blocked when we try to do an insert. So what about updates? We can update the reorder amount to a value outside of that range. Same message, but it says the update statement. So that's how you create a check constraint, and kind of what it does. So let's add a default constraint to that reorder amount column, since we have a definite range on there. So let's just add a default. So the syntax for that is alter table, and the table name, add constraint, the name you want, and then the constraint is a default, and then you say the value for, and then the column. So for reorder amount. So now let's insert a salmon pool entry. And if you notice, there is no reorder amount right here. We're just going to insert category ID, title, and description. And the default that we just created will fill in the reorder amount column. So we run that, look at the data, you can see the salmon pool at the bottom here with the value of 1. So even though it's a kind of an auto-generated number that is defaults in there, we can still update it if we want to. So we'll update the reorder amount to 13 for that record. You can see here that now the value is 13 instead of 1. Okay. For foreign keys, let's create a inventory table. You can see the first column in it is, well, we have the first column is inventory ID, but the first column in the insert statements here is category ID. So we'll create that, do a select from it. We want to create a foreign key on this category ID column to match up with our categories table. So we say alter table, add constraint, and then we name it foreign key this time. Category ID, which is a column in this inventory table. And then you say references, and then the other table you want to reference on category ID. The other table and the column you want to reference. And this column here has to be a primary key on that secondary table. So let's do a kind of phony insert here. So insert into the inventory table. We'll say category ID of 54, which we know doesn't exist in the other table. Oh, I didn't add this. All right. Inventory where category ID equals 54. So it blocked me from creating that foreign key because I had bad data in it that didn't match. So now I've created the foreign key on the table. Let's try to do that insert again with the category ID being 54, which we know doesn't exist. And it doesn't let us. The insert statement conflicted with the foreign key constraint on database table and name. So let's get rid of the foreign key we just created. Alter table, drop constraint, and then the name of it, which is the one we defined it We created the foreign key. Now we can insert our kind of phony data. We can see here that, yeah, all these will match up because we know that there's categories, I think 1 through 9 in the categories table. There's definitely no category 54 though. So now when we try to create our foreign key, it says that we cannot. Alter table conflicted with the foreign key, and it says which column it was on, the column we're creating category ID. So this brings into play the no check rule. So say we're going to have a huge data dump and I don't have time to go and look through my inventory table and figure out which value isn't true. But we don't want any new data coming in to violate that foreign key. So we say with no check. And you can see that we still have that incorrect value in our inventory table. Let's try to insert another one. So a green lantern, and we get that same error message that we can't insert into that table because of that foreign key constraint. So using no check kind of helps us put rules into place earlier. As long as you remember to go back and fix the data that was blocking the initial primary key creation, primary key foreign key creation, then you should be good to go.
Sounds risky.
So yes, it is risky, but in a pinch, or if your business rules a certain way, then it's a good thing to use. It might be that, hey, you just want to have a kind of a temporary foreign key constraint. Just another tool in the toolbox, so to speak. So yeah, we went over the different types of constraints and some vocabulary around data integrity.